years old and scores on the intelligence test at the level of the average 13-year-old. What's his IQ? You need the equation for IQ, and the equation for IQ is 100 times mental age divided by chronological age. And we see that his chronological age, he's 10 years old. So his chronological age is 10, so that's 100, 10, and his mental age is 13 because he's like the average 13-year-old on the test. So his mental age is 13. 100 divided by 10 is 10. 10 times 13 is 130. So his IQ is 130. He's at the age of 10, 3 years ahead. What percent of kids are 3 years ahead at the age of 10? It's the same as the question, what percent have IQs above 130? 2.5%. That wasn't actually asked here, but you should know that from the normal distribution. All right, two theories of heredity, age equals 0 and age equals 1. So we've set it up here. According to the theory that it's all environment and that the environment has to do with being raised together, so we can put here, these are for unrelated, SIBs, dizygotic twins, and monozygotic twins. All that counts is being raised together. They should have the same IQs if they're raised together. And if they're raised apart, the correlation should be 0. And it shouldn't make any difference from row as you go down the rows. The values don't change as a result of how genetically related they are, but the numbers really differ depending on whether people are raised together or apart. So this is a theory. This is the environment theory, the theory that heredity has nothing to do with it and being raised together counts for everything. Now the pure heredity theory, it's also a theory. This is the theory that the environment has no effect. So that means that the numbers in the two columns are going to be the same because the being raised together or apart is going to make no difference. And all that counts is how genetically related are you. So if you're unrelated, it doesn't matter whether you're raised together or apart, those numbers should be the same. SIBs share half their genes, so the correlation should be 0.5. Dizygotic twins share half their genes, so the correlation should be 0.5. And monozygotic twins share all their genes, so the correlation should be 1. So here it's everything has to do with the columns being raised together or apart. Here everything has to do with the rows and no effect of the columns. And then how does it actually come out? And I've averaged over a lot of different studies. You can look at the link and look at what Bouchard has there. Their values that Kellett has put there. Kellett reproduces some data from an earlier paper by Bouchard. In some of the editions, he goes back to a 1980s paper by Bouchard and others. But Bouchard, the 1990 paper that I've linked in the titanium, he gives a value of 0.04 for the correlation in adult IQ between unrelated people reared together. Unrelated people reared apart, 0. SIBs raised together and apart, 0.5 and 0.4. Dizygotic twins reared together, and his numbers are a little different but pretty close to these, and monozygotic twins raised together and monozygotic twins raised apart. Notice there's a small effect, about 0.1 due to being raised together or apart, but there's a big change due to genetics. Now you saw Bouchard interviewed in the program Against All Odds on Correlation. So you saw a little bit of an interview and they talked about some of the personality in this 1990s article. They also report the correlation for height for twins raised together and apart, and the correlation for the California Personality Inventory raised together and apart, and the correlation for the Minnesota Multiphasic Personality Inventory, the so-called MMPI, raised together and apart, and the Strong Interest Inventory raised together and apart, and some other psychological tests, as well as some other tests of scholastic achievement and IQ. So this article, if you're interested in this sort of thing, you can read more details there, and you'll see some different numbers. There have been a number of these. This is the corner that has the least amount of data in it. How often do you get monozygotic twins? That's fairly rare. Those are identical twins, right? Not fraternal twins, which can be same or different in gender. And there is alike genetically as, that's 2 eggs, 2 sperm, 2 babies that are born at the same time, because the pregnancy takes place at the same time, so they're born at the same time. They're conceived within a day or 2 of each other, pretty much the same time. 2 different eggs, 2 different sperm. Monozygotic twins, you have 1 egg, 1 sperm with an extra division, so that you end up with 2 individuals that in theory have the same genes, 2 kids that are as like as peas in a pod. So it's rare to get twins, and then it's rare for twins. So the woman has decided she wants to not bring home the children. Used to have a lot of cases like this in the days when contraceptive information was illegal and abortion was illegal. You had a lot of unwanted children, so people put them up for adoption or did other things with them. So a woman decides she wants to put up children for adoption, and she has monozygotic twins, and they get separated at birth. So the 2 twins are put into 2 different homes. So these data are a lot rarer, and the Bouchard study is one of the studies. There's been some studies done in the UK, in Denmark, in Holland, some other places where people have found identical twins that were separated at birth and raised separately, and then reunited. They have to figure out about each other. Just in the last week, another pair of people found each other who led almost exactly identical lives and somehow bumped into each other and realized they're identical twins that have been separated at birth. So it was just in the news in the last week or so. And these cases show up from time to time, and usually they end up going to Minnesota to be involved in this study. All right, so 2 theories of heredity and environment, fill in the predictions, fill in the empirical results. This particular number here, which has the least amount of data in it, is also an estimate by itself of the heritability coefficient. And what is the heritability coefficient? H is equal to the variance due to heredity divided by the total variance. What's the total variance of IQ? Well, the standard deviation is 15, so the variance is the standard deviation squared, so the variance is 225. How much would the variance be if everybody had the same heredity? According to this, it'd only be 25% of 225, so the variance would be quite a bit smaller if we were all clones. All right. So define the heritability coefficient, and what's its empirical value? It's estimated to go about 0.75 or so. So you'll see estimates about 0.7, some estimates as high as 1 from different studies. There are other ways to compare to estimate heritability. By comparing this number with this number, you also get an estimate. If this is equal, if these 2 numbers were equal, that would be an indication that the environment doesn't make any difference. Another way to estimate is by comparing these 2 numbers. You have 2 people that are born together, so pairs of kids that are twins born at the same time, but these are more similar genetically than these. So this is another way to estimate the heritability coefficient. And so there are a lot of studies that we use just these 2 numbers, so twins that are raised together that are either identical or fraternal, and then there are studies of twins reared together or apart as another way to estimate it. But this number by itself is another way to estimate heritability. And that means that mostly you have evidence for effects of heredity, and not so much on IQ, not so much on the environment. Much bigger effects for the environment on scholastic achievement, right, as opposed to on IQ. Skodak and Skills, any questions so far? So how to compute an IQ? How many got that right? IQ problem? Okay, you need to know the equation for IQ and how to substitute in mental age divided by chronological age. It's not difficult calculation. Any questions about that? So you just need to know that definition. It's on the list of things you should memorize. I have it linked in titanium, things you should know. I noticed that only 20 times has anybody clicked to go look at it. So that means probably less than 20 different people. I mean, maybe one person went and looked at it twice. But it should be, I like it to be bigger than 50 because that gives me the feeling maybe everybody has clicked over there and looked at it. So it's on the list of things you should know. All right, the theories of heredity and environment. Any questions on this before we go on here? So these are two theories, and these are the actual, or like averages of the actual data from a large number of studies. I just sort of averaged out here for you. Here's a graph from Kellett, so you'll see that in here. This particular graph from this particular edition of Kellett, the number for unrelated people reared together is kind of high compared to the numbers I'm giving you. It's also high compared to the number that Bouchard reports in his 1990s paper. What this number is actually is adopted kids reared together, not unrelated people reared together. Why are those two different? Are adopted kids related to each other? In many cases they are. You have two children, a woman gives birth to a child, puts it up for adoption, gives birth to another child, puts it up for adoption, and they end up, by the adoption agencies, going to the same house. Or grandma adopts two children that the daughter can't raise, so the grandmother raises them both. Or auntie adopts two children by a woman who died and left two children, and they end up being adopted by the aunt. So oftentimes adopted kids are related to each other. When you separate that out, the number is smaller for unrelated adopted people reared together. All right. But basically the numbers are pretty much monozygotic twins reared together, that's the biggest number. Monozygotic twins reared apart, that's the next biggest number. Both these numbers are bigger than the husband-wife correlation, which is higher than the parent-child or the sibling-sibling correlations. These two numbers are both higher than sibling. Now you have non-identical twins, you have a number that's a little bit bigger. Non-identical twins are more similar in their environment because they go through the same pregnancy at the same time. So fraternal twins, if the mother gets measles during that pregnancy, it affects both those kids, right? They're fraternal twins. They don't have the same genetics exactly. They share about half their genes, but they have a more similar environment than two other siblings. Because if the mom is healthy through the whole pregnancy, they both get that healthy environment. If the mom gets the measles, they both get exposed to the measles during that pregnancy. If she smokes or drinks or takes drugs during one pregnancy but not the other, they both get exposed to it. So they have a little bit more similar, dizygotic twins have a little bit more similar environment in terms of their biological environment. All right. Skodak and Skeels found that the children adopted from the orphan asylum end up with a higher IQ than those left in the asylum. What kind of data, what sort of a study is this? What kind of relationship is this? Let me see this, going back to the first part of the course. Is this an experiment? No, it's correlational, right? Who gets adopted from an adoption agency? So what you want to do is not fall into the idea of beneficial effects, which we're talking causation here. These are correlational evidence, and so there are multiple possible interpretations. Who gets adopted from the adoption agency? So let's say Daddy Warbucks in the 1930s, back when abortion was illegal, and it was illegal to tell people in many states about contraceptive information. You know, we used to have a lot of strange laws in this country. A doctor was not allowed to give information about contraception to their patients in many states. Why do we have a law like that, you might wonder? Because some people want to get involved in the bedroom, and you know, politicians want to tell people what they can do in the bedroom and not. We've sort of been going away from that over the time. But in the 1960s, the Supreme Court made a ruling that people had a right to privacy. There is no right to privacy in the Constitution, but the Supreme Court sort of created one with the idea that what you would discuss with your doctor should be private. And since then, things sort of changed a little bit in the country. Then the Supreme Court ruled that the states couldn't pass any laws prohibiting abortion during the first trimester. So abortion became legal. And the cause of death due to abortions in the United States dropped suddenly. And the number of kids put up for adoption dropped suddenly. So you had a lot of the drop in the number of unwanted kids. So it became more difficult to adopt. But in the 30s, you had a lot of kids waiting in orphan asylums to be adopted. So which ones get adopted? If you had your choice, if you're Daddy Warbucks, anybody ever read the cartoon Little Orphan Annie? You know, seen the movie, seen the play? Nobody's seen the play, seen the play. It's a hard knock life for us, right? So those of you who know the musical. Yeah. Who are you going to adopt? You going to adopt the kid that's sitting in the corner chewing on their wrist? You know, doing all this kind of stuff in the corner. Obviously peed in the corner there. You know, that you can adopt that one, or you can adopt Little Orphan Annie. You know, the sun will come out tomorrow, bet your bottom dollar that tomorrow. She knows the play. There'll be sun, just thinking about, or the kid that's biting their wrist. You gonna adopt that one? Or are you gonna pick? So it could be the kid who's smart gets adopted, not the kid who's adopted gets smart, right? You don't know whether A caused B or B caused A, or some third factor C caused both A and B, or none of the above. So that when you have a correlation is not evidence of causation. But to convince politicians, you don't need real evidence. And so this had a huge effect politically. So now we don't have orphan asylums in most places. We have, in the state of California, you have the foster home system where the state pays foster families to adopt children so they'll be raised with a family rather than raised in the asylum. And that might be a good thing, but we don't really know from Skodak and Skeels, but that was very convincing back in the 40s. Eventually, by the 60s, you started having these asylums being phased out, and they were to the extent that you could hardly see any, although there have been some calls among some political people for trying to cut the cost of the foster care system, and therefore cut taxes to bring back these orphanages. But we don't really have clear evidence from Skodak and Skeels because it's a correlational study, not a study of causation. Children of rich people have higher IQs, heredity or environment. We don't really know. So correlational things like that are sometimes cited as evidence, but they're not evidence. Now, 23B asks the question, well, if IQ is mostly determined by heredity, does that mean that you can't do anything about it besides genetic counseling and just affect the next generation, or can you do something about it? And Khaled addresses that question, but for most of you, he addresses it in Chapter 3, which you should be reading now. So be sure to read up on Chapter 3, or if for some of you, you've already read it in the chapter on developmental. So it's for some of the editions where he discusses genetics. He talks about the idea, suppose something is produced by genetics, does that mean you can't do something about it? That's the assignment for you to find what Khaled says about that case. Does that mean you can't do something about it? So that's assignment 23B. Any questions about this before we go on? Psych day, homework assignment, or the quiz? I have to give her a chance to ask her question.